This is a very important, significant issue. Crimes in space are yet to happen, from what we understand, but here's how we might solve them when they do. NASA's Artemis program is scheduled to return astronauts to the moon and establish a permanent orbiting laboratory by the end of the decade. Meanwhile, private companies are making significant steps in paying customers further into space. As humanity's footprint expands beyond the familiar terrains of Earth to the moon, and possibly beyond, an intriguing new field emerges from the final frontier, and that is astroforensics. This discipline, still in its infancy, is propelled by the inevitability of human nature. Space presents a unique and harsh environment for forensic investigations, settings that present altered gravity, cosmic radiation, extremes in temperature, and the need for oxygen, providing climate systems provide a few examples of the unearthly variables that are faced by future explorers. Unlike Earth, where gravity, a constant force, shapes many aspects of our reality, the significant reduction of gravity in space introduces novel challenges in understanding how evidence behaves. This shift is crucial for forensic sciences like blood stain pattern analysis, which really relies heavily on gravitational effects to determine the circumstances under which blood stains are formed. The thought of gravity in space immediately conjures images of astronauts hauntingly suspended in the void of space or floating gymnastics in the International Space Station, the ISS. However, true zero gravity exists far away from many celestial bodies. When close to such a body as the moon or the planet, there will be a gravitational influence, including when in orbit around the planet like Earth. Therefore, most environments in space have low or microgravity rather than zero gravity. Given that gravity is ubiquitous and largely constant, we pay very little attention to it, usually automatically factoring it in to calculations as constant without a second thought. Altered gravity? But for a forensic science discipline like blood stain pattern analysis, gravity plays a critical role in how airborne liquid blood interacts with the surface and creates stain patterns. Blood stain pattern analysis is the use of fluid dynamics, physics, and mathematics to understand the flight, and origin of blood and interpret how it was deposited on the surface in criminal investigations. In a recently published study, we and our colleagues, the writers say, sought to understand the beginning principles of how the altered gravity environment of space will affect future forensic science disciplines. For this study, published in Forensic Science International, reports we used a parabolic flight research plane that induces short periods of microgravity because of its up and down flight path. This type of flight has colloquially been referred to as the vomit comet. During this period of free-falling microgravity, a number of blood drops would be projected onto a piece of paper, and the resulting blood stain was then analyzed using routine earthbound protocols. While the concept sounds simple, there was a challenge in creating a safe and controllable area to conduct experiments in a plane that was basically falling to Earth for 20 seconds. Therefore, the experimental environment had to be attached to the cabin of the research plane, and all blood stain generation and documentation made easily controllable. Experiments were conducted inside a repurposed pediatric incubation chamber, referred to as a glove box. This chamber is used in space medicine research for studying hemorrhage control. A synthetic analog of blood was used instead of real blood due to biohazards concerns in the cabin of the plane. This analog substitute mimicked the physical properties of blood's viscosity and surface tension. To initiate the experiment, the analog blood was loaded into a syringe, and once microgravity was induced in freefall, the syringe was manually depressed to project the blood across 20 centimeters onto a sheet of white paper. While this bears little resemblance to true criminal scenarios, it is the interaction between the blood and the surface that is of interest to the forensic investigator. rather than the actual mechanism of projection. The blood-stained papers were then photographed and analyzed as per normal procedures. We found that microgravity does indeed change the behavior of the blood drops and the stains they create. On Earth, blood tends to fall in a parabolic manner, with gravity pulling down on it until it strikes the surface, but in this case the blood continued to travel in a straight line until it hit the surface. This straight line flight path is a fluid example of inertia in action. However, with a distance of only 20 centimeters, this had minimal effect on the subsequent pattern. This difference would become more apparent over large distances, but the operational limitation of the parabolic research aircraft means it would be difficult to recreate effectively. The second key observation was the spreading action of the blood upon striking the surface. In the typical gravity environment of Earth, liquid blood drops will undergo a series of stages in the stain creation process. This entails the droplets collapse, the formation of a small wave, and the spread onto a final stain shape. However, when gravity is eliminated from this action, the spreading action is inhibited by the dominating force of surface tension and cohesion, resulting in a stain shape and size that is smaller than its terrestrial twin. We are at the beginning of a new research era exploring the impact of the extraterrestrial environment upon the behavior of forensic evidence. Still, the impact of this research is not only limited to forensic sciences, but more traditional natural sciences as well, such as fluid dynamics and spacecraft design, and analyzing faults in space forensics engineering following a spacecraft malfunction. In order to expand research in this new forensic discipline, larger microgravity environments will be required, and the authors would be more than happy to operate the galaxy's first extraterrestrial forensic science laboratory. And this is from the conversation published under Creative Commons, by Graham Williams, Professor of Forensic Science, University of Hull, and Zach Kowalski, PhD researcher, Staffordshire University of the UK. And this is on Science Alert. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.